So let us study in this chapter, as I have told you, that we are going to study only binary solution. Okay. So let us study about the Vapour pressure of binary solution, where we are taking solid and liquids only, right? In binary solution, the solvent is mainly volatile in nature, that can be easily evaporated. In Vapour pressure, what is Vapour pressure? It is the force exerted by a liquid, as you can see here. It is the force exerted by a liquid, or say solids, rising above the surface, right? In a closed container at a specific temperature, the pressure forms in thermodynamic equilibrium. Okay. Right. So the equilibrium vapor pressure, it can be used to calculate rate of liquid evaporation. So vapor pressure is simply what? It is the force exerted by a liquid. Okay. And when vapor started rising above its surface. Right. Let's talk about the vapor pressure of liquid solutions. Liquid solution, where we are taking solvent as a liquid and solute as a liquid, right? Let us consider a binary solution. Binary solution is what? Which are having two components. Okay, let us consider a binary solution of two volatile liquids. Say their names are 1 and 2. Okay, in a closed container, liquid would evaporate due to its nature, obviously. Okay, so here comes in action the very important Raoult's law. Okay, that is for solution of, that is for liquid solution, or say for volatile liquids. Okay, at a particular temperature, here the third point will be skipped. The particular temperature, equilibrium is created between the liquid phase and a vapor phase. This is understood that at some point there is an equilibrium. Equilibrium is what? Where an equal, or say constant, or say static position, or say static force takes in place, right? Where there is no net change observed, right? So at particular temperature, equilibrium is created between liquid phase and a vapor phase. This is liquid phase and a vapor phase. This which is forming above, right? Let us now study about Raoult's law. What is Raoult's law? So let me give you some little brief about Raoult's law, that who discovered this. It is discovered by French chemist. Okay, in 19th century. The name of the scientist was Francois Marie Roth. Francois Marie Roth. Okay, so he have given in 19th century Raoult's law after his name, which is for the vapor pressure of volatile liquids, right? It states that partial pressure of liquid, or say each liquid component, it is directly proportional to the mole fraction present in the solution. Mathematically, how we write this? That partial pressure of a liquid is equal to, sorry, it's directly proportional it is directly proportional to the mole fraction present in a solution. Okay, let us study this in detail. Here you can see the derivation of Raoult's law. Mathematically, it is directly proportional to the, this P1 is vapor pressure of a liquid that is directly proportional to the mole fraction. Alright. And we can remove this proportionality constant is equals to x1. Let me write it here. So partial pressure of a liquid was directly proportional to the mole fraction, which is equals to now what this means here. PA is the vapor pressure of what? Of a solution. XA is what? This is mole fraction. Mole fraction of what? Solvent. And this P naught, this is what? Vapor pressure of pure solvent. Alright. Or it is also known as proportionality constant. Proportionality constant. So I hope you know this is very important to know the Rolls law. It is often asked in exam to derive Rolls law. You should know that this is directly proportional to the mole fraction of a component, okay, mole fraction of a solvent. And by removing this directly proportional sign, we can write PO, which is the proportionality constant. All right, you can read this here also. Right, here it is given as per Dalton law of partial pressure. What is Dalton law? It is the sum of all the, or say, total pressure exerted over solution phase. Okay, it is known as P total of the partial pressure and the mole fraction. Right. Solvent. All right. So let us read here quickly about the important conclusion derived from this P total. What is this? This is the Dalton's law that we have used by applying Rod's law and Dalton's law of partial pressure. What is Dalton law? The product and sum of the mole fraction and partial, or say, vapor pressure of the solvent. Right. The Rod's law as a special case for Henry's law. Like, what are we going? We are going to discuss the similarities which we have already discussed. As you know, what was the Henry's law? Partial pressure of gas directly proportional to mole fraction. What was the Rod's law? Slight difference, that partial pressure is equals to the mole fraction into vapor pressure of pure solvent, right? If we compare both these above equations, we can conclude that the partial pressure of a volatile substance, or say a gas, is directly proportional to the mole. If we, our next topic regarding vapor pressure of liquid solutions. If you can see here we are having liquid plus liquid. Here the red spot are for solute, or say solid particles, and blue one is for solvent, right? If I ask you which vapor pressure is high, this vapor pressure is high. Why? Because the solute particles present here, it will cover the surface of liquid. Okay, it will cover the surface area of solvent particles. So that is why there will be decrease in the vapor pressure of solute plus solvent particles. Understood? And here liquid particles, as the surface area is greater, is greater, so vapor pressure will be high, right? So you can easily answer the question if it come in the exam. Vapor pressure of solution of solid in liquid, that's solvent or say liquid solution, they are having high vapor pressure. Why? Because they are having they are having their surface area is greater. Okay, but in case of solute and solvent, as the solute molecules, they are covering the surface area of the solvent, that is why vapor pressure will decrease. All right, so this is what it written here. If you can read it, as the surface area has both solute and solvent particles, the vapor pressure exerted by solution gets lower. All right, so I hope this topic is clear to you.